Welcome to lecture 2 of week 6 on isometric drawings. In this lecture we will be looking at how to construct isometric drawings. In the previous lecture we have looked at different pictorial drawings and concluded by saying that isometric drawings are the most commonly used drawings. So, usually what happens is you already have an object and you need to prepare the isometric drawings. That is a relatively easy task because you have the object in front of you. So, you do not need to struggle with capturing the mental picture of it. The other challenge is you are given the multi-view drawings and then asked to draw the isometric drawing. Then there is an intermediate step where you need to first, based on this multi-view or the orthogonal views, you need to have a mental picture of the object, and using that mental picture then you need to draw the isometric drawing on a paper. So, that is a relatively more challenging task because then it depends on how well you are able to get that mental picture based on the multi-view drawings. So, in this lecture what we will do is we will take 4 examples, each with a different feature of it, and try to explain how to start drawing these isometric drawings in a systematic way. So, that after a while you get a it becomes easy for you to draw the isometric drawings. So, let us start with a simple one where we say that the object has normal faces. What I meant by normal faces? Saying that all faces of the object are parallel to at least one of the principal planes. What do I mean by principal planes? We said the object is in space and we define the object in space using 3 axes. So, because we are using the Cartesian system, and these 3 faces, these 3 axes make 3 different planes: the horizontal plane, vertical plane and the perspective plane, profile plane. So, these 3 planes are perpendicular to each other. Now, what I am trying to say is, for example, this object, all faces, it has 6 faces and all of those faces are parallel to at least one of these horizontal, vertical or the profile plane. So, for example, the front view is parallel to the vertical plane and the side view is parallel to the profile plane and top view is parallel to the horizontal plane. Okay. The point being is, then it becomes easy to draw the isometric drawings, and it also becomes easy for you to understand it from the multi-view drawings. All these faces, when they are parallel to one of those planes, it appears as a area in one of the planes, and in the other 2 projections it only appears as an edge. So, let us focus on the top view. So, this top surface of this object, only in the top view it is captured as an area, but in the front view we only see this edge, and also in the side view we only see it as edge. So, which means this surface is captured as area in one view and as an edge in 2 views. That goes with all the surfaces of this cube or a solid which is shown here. Okay. So, that helps us to identify whether your surface is a normal surface which is parallel to one of the projection planes or not. So, with a little of intuition, we should be able to see that these multi views will lead to this object shown in the slide. Now, the point is, how do we start to draw this object in the isometric view? So, the first step is to draw the isometric axis. So, we know that the isometric axis, all these axes make equal angles, and as shown here these are 120 degrees apart. So, we do not show those angles, we only draw the isometric axis. So, let us say this is the point where we start from. Then what we say is, we need to first decide in this object what is the front view. So, here looking at the orientation of the views, we know that this is the top view, front view and the side view, and since the top view is placed above the front view, we know we are in the third angle projection. So, this should be the right side view. Okay. So, which means for this object the front view should be shown using an arrow like this. So, once we show that the front view is this, then we know this is the width, the height is here, and this is the depth. Okay. So, we start to draw this object using this corner point which is placed here. Okay, let us label it as O for convenience. Okay. Now, what we do is for example, if I want to capture this front view, especially this face, should I do it to the left of point O or to the right of point O? So, that should be captured to the left. The front face with width. So, the front face has the width and the height that is drawn to the left. And similarly, how do we capture this side view or this surface which is appearing in the side view? That we capture to the right of point O. Draw the side face which has the depth and height to the right. So, once we capture these front face or the side face, the rest you can draw parallel lines and connect to complete the solid. So, the rest is completed by drawing parallel lines to axis. So, at least in this example we know all of them are normal faces, which means they are all, most of them are parallel to the axis. Okay. So, with this we are able to complete this simple object. Next, in the next example we will introduce a slight complication. The object has both inclined and oblique face. Now, let us first explain what is an inclined surface and an oblique surface. So, let us say one of the face is perpendicular to the vertical plane. So, this surface, the surface where I have this circular patch, when it is oriented in this direction, it is perpendicular to the vertical plane, but it is at an angle to the profile plane as well as it is at an angle to the horizontal plane. So, this we call it as the inclined face because it is perpendicular to one of the planes. But let us say if I tilt it in a way that this surface is neither parallel nor perpendicular to any of the three principal planes, the horizontal, vertical and the profile planes, then we call it as the oblique faces. The reason why I am emphasizing this is, now let us first start with an inclined face. So, now we said this, the one with the circular patch is the inclined face. So, when you capture the front view, what do we see? We see this surface is captured as an edge. What about the side view? Side view we see it as an area. How about the top view? Top view also we see it as an area. So, which means for an inclined surface you capture one edge and two areas. Similarly, now let us look for the oblique face. For the oblique face we said this is neither parallel or perpendicular to any of the axes. So, let me place it in this fashion. So, if it is placed in this fashion, how will it look in the front view? In the front view you look it as an area. How about in the side view? Side view too you look it as an area. Similarly, in the top view it comes out as an area. So, which means in none of the views it comes out as an edge, and all three principal views it comes out as area. So, three areas in the three principal views. Okay. So, now let us look at this multi-view drawing and try to identify if we can see any inclined or oblique face. So, if you notice this triangle, we see it in all three views. Since an oblique face we know shows up as an area in all the three views, we can assume that this triangle is an oblique surface. but let us say let us focus on this edge. So, this edge in the, let me first write it as top view, front view and right side view. So, this edge is an edge in the front view, but whereas if you look at the top view it is an area, and if you look at the right side view it is an area. So, that should give us a clue that what we are looking at is an inclined surface. Okay. So, with this small clues we should be able to identify that this object has one inclined surface and one oblique surface. So, this is how the object looks like. But now let us see step by step how do we draw the isometric view. Like previously we will start with an isometric axis. We will first draw the isometric axis, and since we said this captures the front view, so we have the width here, the depth here and the height here. Of course, all the vertical lines are height. So, this should capture us, this axis should capture us the width, this should capture us the depth and this should capture us the height, the vertical line, the height. Okay. After we are done with the isometric axis, that is when we start with capturing the front face. We can also do the right face to the right of this center point. Let us say O, we call it as the center point, which is this bottom point O. We start with this bottom point O because that is relatively much closer to the viewing place. Okay. So, and then for the features seen in the front view we capture it to the left, and those seen in the side view we capture to the right. So, we start proceeding with this, and the important point is how do we capture the inclined and the oblique faces. So, we always do this by focusing on the corner points. So, for this inclined surface we focus on these 4 corner points. Let us just for convenience let us name it 1, 2, 3 and 4. And for this oblique surface we will again focus on the corner points. So, O is already there. So, let us say that 5 and 6. Okay. So, once we are able to trace where these points 1 to 6 go in the isometric view, then it becomes easy to develop the solid, because then you just need to join those points. So, first you only need to focus on where these points are lying on the isometric drawing. Okay. So, with red lines here are the construction lines. So, with these red lines we are able to find points 4 and 5. Essentially we draw intersection of vertical lines and these lines parallel to the width axis to capture these points 4 and 5. Similarly, we continue. See, point 1 is already captured. Let me also name this point 4 and point 5 here. Similarly, we keep continuing and capture the points 3 and the rest. Now, we are left with how do we capture the oblique surface or the oblique face. For that, again as we said, we have already captured 2 points of the oblique O and 5. We are left with capturing this point 6. How do we capture point 6? So, we first draw these lines parallel to the width and the depth and try to capture this point, and then we just need to draw parallel lines to the depth. Once we draw parallel lines and measure the length, we have captured this point 6. So, once we capture points 5, 6 and O, we can simply draw the oblique surface by connecting these points. Okay. So, with this we are able to capture both the inclined and the oblique faces on a object. And later we will now move to the next example where we are trying to capture a circular hole. So, I think we have already discussed previously saying that if you are focusing on this circle and if I hold it in this fashion in the front view, it looks like a circle. But the same circle, if I am now oriented in this fashion where we are trying to capture the isometric view, this circle now looks like a ellipse. But how do we draw an ellipse in an isometric view? So, we do that by following one method called the 4 center method. There are other methods too, but the 4 center method is more commonly used. So, the example I take is something like this. Here the final object looks like a block, and on this face I want to capture the circle. So, since the width of the block is not too much, in this example what happens is we will also be able to look at this circle from the behind surface, not on the front surface, but at the back surface also. So, that will be captured with another arc like this. Okay, but now let us look at how do we do that in a step by step manner. So, first we will again draw the isometric axis, and second I will draw the block because we already have seen in the previous 2 examples how to draw a simple block. So, we will draw this block which I call here as the cuboid, because all the 6 faces of this block are parallel to at least one of the principal planes. Okay. Next is the point where we try to start capturing the circle as an ellipse in the isometric drawings. For that, what I do is first identify what is the diameter of this circular hole and then draw a square in the face. So, the size of the square is the circle diameter. So, let us say d is the circular diameter, then this length 1 2 is the diameter. Okay. So, what I have done is first located the center of this face, and using that center I have now constructed a square. Of course, a square is depicted as this parallelogram in the isometric view. So, the points 1, 2, 3, 4 capture the square, and I also have captured the midpoints of the square, which are these points A, B, C and D. Okay. Now, what we do is we join points 1 to points B and C. The reason we do it is we need to measure this length from 1 to B, we measure it as arc, and using a compass we draw an arc now. So, what we do is we draw this arc CB with center at A, this should be 1, with center at 1 and radius as 1B. Okay. So, now we are able to draw this arc BC. Using the same method, we should be able to draw the arc AD. So, for here the center will be at 3 and the radius will be the same radius 1B you can use, or just to show it here, this R what we say show it as 3A. Okay. So, now we have completed 2 arcs, we need 2 more arcs to complete this ellipse. For that, we locate these center points where these construction lines meet and name them as points E and F. What are points E and F? Those are the points which are intersected by these construction points. Now, I take another radius. So, my radius is small r here, which is ED, that I can measure with the compass, and with center as E I draw this arc DC. So, this is the arc I have just drawn. Similarly, using the same radius, but now with center at F I can draw another arc AB. So, once I draw these 4 arcs with 4 centers, that is why we call it as the 4 center method, we are able to completely capture that ellipse. So, as we said this circle is now captured as an ellipse in the isometric view. Of course, you can use the same method to capture the ellipse not just on the, let us say this is the, let us say in this case this is the front view. We can use the same method to capture it either in the side view or the top view. Okay. But we are left with one last point. How do we capture the circle from the surface, back face of this block? For that, what we need to do is we need to just draw parallel lines from points C, F, E, F and B, and then use the same method to draw the arcs. Okay. So, if you use the same method, basically we are just drawing parallel arcs now. To draw the parallel arcs, we use this depth axis and draw parallel to the depth axis, and the width of this depth axis is given by this depth of the block. So, using the same method, we are also able to capture the second arc, which captures the circle or the hole in the back face. Okay. So, with this we complete the third example, and now let us look at the last example where I want to show how do we project onto an inclined surface. So, these are the orthographic projections or the multi views of an object. As you can see here, I hope you can see that in the top view you can see a hexagonal cut, but once you look at the front view and the side view, this hexagonal cut is shown using hidden lines. Okay. So, as you can assume that this is how the final object will look like. In the final object, you see that on this inclined surface we have this hexagon, but will it be the same hexagon that we see in the top face? No, it is slightly distorted. But how do we capture this distortion? For this, what we do is we focus on the 6 corners of this hexagon, and then let us say if we are able to pinpoint where these 6 points of the hexagon are there on the solid, then we just need to connect those points to capture this distorted hexagon. So, essentially what we are saying is we need to first draw the hexagon in the isometric view. First, now let us draw the block without the hole. So, this should be relatively easy now, because we have already covered how to draw object with normal faces or with inclined and oblique faces. So, let us assume that we are done with constructing this block. Now, we need to capture that hexagon on the inclined surface. So, we said that let us first draw the true size of this hexagon on the top face of this object. So, if you notice, I am drawing these with construction lines which are thin. So, what I am now drawing is this hexagon in the true size on the top surface of this object. Again I am repeating that I am drawing these with thin lines, because these are part of construction lines. These are not how it looks like in the final step, but I am using this to construct the distorted hexagon on the inclined surface. Okay. So, now we have this hexagon in this true size and size on the top face. So, how do I project these points? So, let us name these points 1, 2, 3, 4, 5 and 6. So, these points, if I can project it onto the inclined surface, then I just need to connect those points to show you how it looks like. So, for that what we do is we use this top face, and let us say we are focusing on points 5 and 6. So, on the top face we draw 2 parallel lines, and note these points where it intersects with the edge of this bigger box, and then we draw vertical lines such that they come and intersect with the inclined line, and again we draw parallel lines parallel to the, let us say, if this is the, okay, yeah, this is the front view. So, this is the width, depth and the height. So, again we draw parallel lines to the width to capture what are points 5 and 6. So, let us say these are 6 dash and 5 dash. The length of these lines is similar to the length in the top face. So, this length and this length are the same. So, essentially what we have done is we started with point 6, we draw a line on the top surface, then draw a line on the side surface and then draw a line on the inclined surface. Where after drawing these 3 lines, we end up with the projection of this point 6. Similarly, we have done the same for point 5. So, once we projected points 5 and 6, we can join them to get the one edge of the hexagon. So, we repeat the same procedure for the remaining points. So, for now let us focus on point 4 and then join the lines. And similarly, we can now do it for lines 1, 2 and 3. When we are drawing these projection lines, I can use the other side of the block. So, again these construction lines to project these points 1 dash, 2 dash and 3 dash. And I now have already projected all the 6 points. Now, I can draw the complete hexagon on the inclined surface. The last thing is I forgot to capture the cut. How do we capture the cut? As you can see here, we need to show these vertical lines because those are still visible in the angle we are looking at. So, let me select a black surface, black color. So, I just need to draw a vertical lines from point 3 dash and vertical line from 2 dash to complete this object. Okay. So, with this we are done by capturing this hexagon on the inclined surface, but as you can see, maybe someone might be thinking, can we do these projection lines instead of on the side faces, can we do it on the front face? This I will quickly show in the last slide. So, again the same problem, so I am not repeating it again. The only difference now I am trying to say is, when we draw projection lines, there is one other alternative. Instead of going to the side view, we can also go into the front view. So, as you can see, we have drawn lines in the top view, then the front view and again the inclined surface. And then lastly, we just need to draw vertical lines to project the depth. So, with these we capture 2 points. Let us say these are points 1, 2, 3, 4, 5, sorry 5 and 6. This will be 5 dash and 6 dash. So, we join those 2 points. Similarly, we can follow the same method again to capture projections of point 4 and again 1, 2 and 3. So, once you got all the 6 projection points, we connect them to get the projected hexagon. And lastly, we also draw these edges which represents the cut, the hexagonal cut. With this we are done to show the 4 examples. Essentially, in summary, what we have seen in this lecture is how do we draw isometric views for an object with normal surfaces. We said a normal surface is one which is parallel to one of the principal planes. So, for example, this surface will look as an edge in 2 of the principal views, but as an area in one of the principal views. So, it looks at 2 edges and 1 area. And as a inclined surface, we said we look it as one edge in one of the principal views, and in the other 2 principal views it looks as area. But for the oblique, in all 3 principal views it looks as an area. And later we said that the circles, they look as ellipse in the isometric view, and we have looked at the 4 center method how to draw this ellipse. And lastly, we said if we need to project something on these inclined surfaces, there is one method where we first draw the true view or the true shape, and then we follow the corner points of the shape. For example, in this example we have looked at hexagon, we have followed the 6 vertices of the hexagon and projected them onto the inclined surface. Once we capture those 6 points, we connected them to show the final view how that hexagon looks on the inclined surface. Essentially, we can extend these techniques even for curves. For curves, what we just need to do is we need to break that curve into multiple segments and then focus on multiple points on the curve. So, if you can project these curve points on the curve on the isometric drawing, then we just need to connect those 2 points to appear it as a curve. Only thing is, these points, if they are closer to each other, then you can connect it with a smooth curve, otherwise it becomes a little tedious. Okay, I hope all of you got at least an intuition about how to get started with these isometric drawings, and we have looked at few principles, so you can understand how you can implement these principles in drawings. As we all know, like drawing comes with practice. So, I would encourage all of you to start practicing, and then you will be able to get a hang of these principles, how to apply them in more complex objects as well. Okay, thank you for your attention.